What if I told you that everything you see around you, every galaxy, every star, every planet, even every atom that makes up your body, is only a tiny fraction of what actually exists in the universe? Not because the rest is hidden behind a wall or far away in some unreachable place, but because most of reality itself is invisible, silent, and deeply mysterious. Right now, as you watch this video, the universe is not just expanding, it is accelerating, being pushed apart by an unknown force that scientists have named, almost reluctantly, dark energy. It doesn't glow, it doesn't clump, it doesn't interact with light, yet it dominates the cosmos. So what exactly is dark energy, and why does it control the fate of everything that exists? Welcome to Cosmic Horizon Hub, where today we dive into one of the greatest mysteries of modern science. To understand dark energy, we need to start with a simple but mind-bending observation. When astronomers look at distant galaxies, they notice that almost all of them are moving away from us. This discovery was first made in the 1920s by Edwin Hubble, who showed that the universe is expanding. Imagine dots drawn on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot. There is no center on the surface, and no dot is special. This was revolutionary, but for decades, scientists assumed that the expansion should be slowing down. After all, gravity pulls things together. Galaxies have mass, mass creates gravity, and gravity should act like a cosmic brake. The universe should be expanding, yes, but gradually losing speed. That assumption made sense, and for a long time, no one seriously questioned it. Then, in the late 1990s, everything changed. Two independent teams of astronomers were studying distant Type Ia supernovae, exploding stars so bright they can be seen across billions of light years. These supernovae act like cosmic mile markers. Because they explode with nearly the same intrinsic brightness, scientists can compare how bright they appear to determine how far away they are. By measuring both distance and redshift, astronomers can reconstruct how fast the universe was expanding in the past. What they found was shocking. The distant supernovae were dimmer than expected, meaning they were farther away than they should be. The expansion of the universe was not slowing down, it was speeding up. Something was pushing space itself apart. This unknown driver of acceleration was given a name that reflects our ignorance more than our understanding. Dark energy? Here comes the first big twist. Dark energy is not a small effect. It is not a minor correction. According to the best measurements we have today, dark energy makes up about 68% of the total energy content of the universe. Dark matter, another mysterious component, contributes about 27%. Everything we know and love, stars, planets, gas, dust, people, black holes, all of it combined, makes up less than 5%. Let that sink in. The universe you can see is almost irrelevant compared to what you cannot. So what is dark energy actually doing? To answer that, we need to talk about space itself. In everyday life, we think of space as emptiness, a passive stage where events happen. But according to modern physics, space is dynamic. It can stretch, curve, and carry energy. Dark energy appears to be a property of space itself. As the universe expands, more space comes into existence, and with it, more dark energy. That means the total amount of dark energy increases over time, even as matter becomes more diluted. This leads to a runaway effect. More space creates more dark energy, which causes even faster expansion, which creates even more space. It is a cosmic feedback loop. One way to visualize this is to imagine space as a fabric under tension. Instead of gravity pulling the fabric inward, dark energy acts like a pressure, pushing it outward, evenly, smoothly, everywhere at once. Unlike matter or radiation, dark energy does not clump. It does not form galaxies or stars. It is the same in empty voids and crowded clusters. It is uniform, subtle, and relentless. Now let's address a question you might be asking right now. Is dark energy the same thing as dark matter? The answer is no, and confusing them is very common. Dark matter pulls. Dark energy pushes. Dark matter acts like invisible glue, holding galaxies together and shaping the cosmic web. Dark energy does the opposite, driving galaxies apart on the largest scales. They share the word dark only because we cannot see them directly. Their roles in the universe could not be more different. Here comes another twist, one that connects dark energy to one of the greatest minds in history. In 1917, Albert Einstein modified his equations of general relativity by adding a term called the cosmological constant. He believed the universe was static, neither expanding nor contracting, and this extra term provided a repulsive force that balanced gravity. When the expansion of the universe was discovered, Einstein reportedly called the cosmological constant his greatest blunder. He removed it. But decades later, with the discovery of cosmic acceleration, the cosmological constant came back, and suddenly, Einstein's mistake didn't look like a mistake at all. Today, the simplest explanation for dark energy is that it is exactly this cosmological constant, a constant energy density inherent to empty space. If this is true, then dark energy has the same strength everywhere and at all times. But simplicity does not mean certainty. Physicists are deeply uneasy about this explanation because when they try to calculate the energy of empty space using quantum field theory, they get a value that is wildly wrong off by a factor of up to 10 to the power of 120. That is the worst theoretical prediction in the history of physics. So either our understanding of quantum vacuum energy is fundamentally flawed, or dark energy is something else entirely. This brings us to more exotic ideas. Some scientists propose that dark energy is not constant but dynamic, something that evolves over time. These models often go by names like quintessence, a hypothetical field that fills space and changes slowly as the universe expands. In this picture, dark energy today might not be the same as dark energy billions of years from now. It could weaken, strengthen, or even reverse. If that sounds dramatic, it is, because the fate of the universe depends on it. If dark energy remains constant, the universe will continue expanding forever, galaxies drifting farther apart, stars eventually burning out, leading to a cold, dark future known as the heat death. If dark energy grows stronger, expansion could accelerate without limit, eventually tearing apart galaxies, stars, planets, and even atoms in a catastrophic scenario called the Big Rip. If dark energy weakens or changes sign, expansion could slow, stop, and reverse, ending in a big crunch. Right now, our best data suggests something close to a cosmological constant, but the uncertainty leaves room for surprises. Here is a fascinating question and answer moment. Can dark energy be detected directly? The answer is no, at least not yet. We infer its existence only through its gravitational effects on cosmic expansion. We measure how fast galaxies move away from each other, how light bends as it travels through space, and how structures grow over time. Dark energy reveals itself only through what it does, not what it is. That makes it one of the most elusive entities ever proposed. Another question: does dark energy affect us here on Earth? The honest answer is no, not in any noticeable way. On small scales, gravity, electromagnetism, and nuclear forces completely overwhelm the effect of dark energy. It only becomes dominant over immense cosmic distances, between clusters of galaxies and across the universe as a whole. Dark energy is the ultimate large-scale phenomenon. It shapes the destiny of the cosmos, but leaves your daily life untouched. Yet its philosophical implications are profound. Dark energy tells us that the universe is not just expanding because of initial conditions set by the Big Bang. It is being actively driven apart by something intrinsic to space itself. The emptier the universe becomes, the more dominant dark energy grows. Emptiness has power. That idea alone challenges our intuition. Let's add one more twist. Dark energy might be connected to the early universe as well. During the first fraction of a second after the Big Bang, the universe underwent a brief period of extremely rapid expansion called inflation. Inflation was driven by a mysterious energy field with properties strikingly similar to dark energy. Some scientists wonder if dark energy is a faint echo of that primordial force, still at work billions of years later. If true, dark energy could be a clue linking the birth of the universe to its ultimate fate, a bridge between the beginning and the end of time. As observations improve, new telescopes and missions are hunting for answers. Projects like the Euclid Space Telescope, the Vera Rubin Observatory, and future space missions aim to map billions of galaxies, track cosmic expansion with unprecedented precision, and test whether dark energy truly is constant. Tiny deviations could reveal entirely new physics. We are living in a golden age of cosmology, where questions that once belonged to philosophy are being attacked with data. So where does that leave us? Dark energy remains one of the greatest unsolved problems in science. It dominates the universe, controls its expansion, and determines its future, yet we do not know what it is. It could be vacuum energy, a new field, a modification of gravity, or something we have not yet imagined. Every answer we propose opens deeper questions. But that is exactly what makes it exciting. Dark energy reminds us that despite all our technology and equations, the universe still holds secrets vast enough to humble us. If you could stand at the edge of the observable universe and watch galaxies fade into darkness, pulled away not by an explosion, but by the quiet pressure of space itself, you would be witnessing dark energy in action. A force with no face, no light, no sound, yet enough power to shape everything. And the final question is this: are we on the verge of understanding it, or is dark energy telling us that our current theories are only scratching the surface of reality? If this mystery fascinates you as much as it fascinates us, write your thoughts in the comments below. Do you think dark energy is a simple constant, or a sign of new physics waiting to be discovered? If you enjoyed this deep dive into the universe, don't forget to like the video, share it with fellow cosmic explorers, and subscribe to Cosmic Horizon Hub for more journeys beyond the edge of the known universe.